The year was 1972. It was a time of great change and monumental achievements. The world was in the midst of the Cold War, and the space race was at its peak. Technology was advancing at an unprecedented rate, and humanity was reaching for the stars. The world watched in awe as Apollo 16 landed on the moon. It was a moment of triumph for NASA and a testament to human ingenuity and perseverance. The lunar surface, with its desolate beauty, became a symbol of what we could achieve when we dared to dream big. But far away, another spacecraft was beginning its journey. This was not a mission of exploration, but one of ambition and competition. The Soviet Union, determined to showcase its prowess, launched a probe that aimed to reach the mysterious planet Venus. This was Kosmos 482, a Soviet probe destined for Venus. Part of the Venera program, it was designed to study the planet's atmosphere and surface, providing valuable data that could unlock the secrets of our neighboring world. Now, after over 5 decades in space, Kosmos 482 is coming back to Earth. Its journey has been long and arduous, traveling millions of miles through the void of space, only to find its way back to the planet it once left. This isn't a planned landing. The spacecraft's return is a result of the relentless forces of nature, pulling it back towards Earth. It's a stark reminder of the challenges and unpredictability of space travel. The mission failed shortly after launch. Technical issues and unforeseen complications led to the probe being stranded in Earth's orbit, unable to complete its intended mission to Venus. Ever since, Kosmos 482 has been trapped in orbit around our planet. It has circled the Earth countless times, a silent witness to the passage of time and the advancements in space technology. But Earth's gravity is relentless. It exerts a constant pull on everything in space, slowly but surely drawing objects back towards the planet. This invisible force has been working on Kosmos 482 for decades. It pulls on everything in space, slowly dragging this silent relic back down. As Kosmos 482 descends, it serves as a poignant reminder of our early ventures into space and the enduring impact of those pioneering missions. The spacecraft's return is not just a physical event, but a symbolic one, highlighting the relentless march of time and the ever-present influence of gravity. The Soviet Union had ambitious plans to explore the vast reaches of our solar system. During the height of the space race, they were determined to push the boundaries of human knowledge and technology. Their engineers and scientists worked tirelessly, driven by the desire to achieve what had never been done before. They envisioned missions that would take humanity beyond the confines of Earth, to the distant planets and moons that make up our solar system. Each mission was a step into the unknown, a bold leap into the cosmos. Venus, our closest neighbor, was a prime target for these exploratory missions. Known as the morning star and the evening star, Venus has always fascinated astronomers with its bright, shining presence in the sky. But beneath its thick clouds lies a world of mystery and extreme conditions. Kosmos 482 was part of a series of spacecraft designed to land on this mysterious world. The Venera program, which included Kosmos 482, aimed to gather unprecedented data about Venus's atmosphere, surface, and potential for life. These probes were supposed to pierce the thick clouds of Venus, which are composed mainly of carbon dioxide and sulfuric acid. The descent through the atmosphere was a perilous journey, with temperatures soaring to over 450 degrees Celsius and pressures crushing enough to flatten most spacecraft. Once through the clouds, the probes would then send back data about the planet's surface. This data was crucial for understanding the geology, climate, and potential for past or present life on Venus. The information gathered would help scientists piece together the planet's history and its place in the solar system. This was cutting-edge science at the time. The technology and methods used were at the forefront of space exploration, pushing the limits of what was possible. The dedication and ingenuity of the scientists and engineers involved were truly remarkable. But Kosmos 482 never got the chance to complete its mission. Despite the best efforts of the Soviet space program, the spacecraft encountered technical difficulties that prevented it from reaching Venus. It remains a testament to the challenges and uncertainties of space exploration, a reminder of the risks taken in the pursuit of knowledge. A rocket malfunction spelled disaster for Kosmos 482. The probe was stranded in Earth's orbit. Instead of studying Venus, it became another piece of space junk. For decades, Kosmos 482 silently circled our planet. It posed no immediate threat, but every orbit brought it a little closer to Earth. The pull of gravity was slowly winning. As Cosmos 482 descends, it encounters the upper layers of our atmosphere. This is where the air gets thicker. Friction builds up, causing the spacecraft to heat up. Most of it will burn up during this fiery re-entry. But Cosmos 482 is tough. It was built to withstand the harsh conditions of Venus. Some parts, like the landing capsule, might survive the fall. These fragments will then plummet towards the Earth's surface. Section 5. Where will it land? Predicting the exact landing site of a spacecraft re-entering Earth's atmosphere is a complex and challenging task. Scientists use a variety of tools and models to make their best estimates, but there are many variables at play. The speed, angle of re-entry, and even the shape of the spacecraft can all influence where it will ultimately land. Kosmos 482, a Soviet-era spacecraft, is currently tumbling through space. This uncontrolled motion adds another layer of unpredictability to its re-entry. Unlike modern spacecraft, which are designed to re-enter the atmosphere in a controlled manner, Cosmos 482's erratic movement makes it much harder to predict its landing site. Even small changes in its trajectory can have a big impact on where it lands. For instance, a slight shift in its angle of descent could mean the difference between landing in the ocean or on land. Scientists continuously update their models to account for these variables, but the inherent unpredictability remains. Based on current data, scientists estimate that Cosmos 482 will come down somewhere between 52 degrees north and 52 degrees south latitude. This range encompasses a vast portion of the Earth's surface, including parts of North America, Europe, Asia, and much of the southern hemisphere. This is a vast area covering much of the Earth's surface. The sheer size of this potential landing zone highlights the challenges faced by scientists in narrowing down the exact location. They must consider numerous factors, including atmospheric conditions, the spacecraft's speed, and its angle of re-entry. The most likely scenario is that it will splash down in the ocean. Given that over 70% of the Earth's surface is covered by water, the odds are in favor of an ocean landing. However, until the final moments of re-entry, the exact landing site will remain uncertain. Scientists will continue to monitor Cosmos 482's trajectory closely, providing updates as new data becomes available. Section 6. Built to survive. While the thought of a spacecraft falling from the sky might seem alarming, there is no need to panic. The chances of anyone being hit by debris are astronomically small. Furthermore, Cosmos 482 is relatively small. It's only about 3 feet in diameter. Even if parts of it do survive re-entry and land on land, they are unlikely to cause significant damage. Section 7. A growing concern. Cosmos 482 is a stark reminder of a growing problem: space junk. There are millions of pieces of debris orbiting our planet. These range from defunct satellites to tiny fragments of rockets. This space junk poses a hazard to active satellites and spacecraft. Collisions, even with small objects, can cause serious damage. As we launch more objects into space, the problem of space debris will only get worse. Section 8. What goes up? What can we do about space junk? Scientists and engineers are working on solutions. These include developing ways to track and remove debris from orbit. There are also international agreements in place to encourage responsible behavior in space. It's essential that we address the issue of space junk. Our future in space depends on keeping Earth's orbit a safe and sustainable environment for all. Section 9. Keeping an eye on the skies. The re-entry of Cosmos 482 is a fascinating event. It reminds us of the challenges and wonders of space exploration. While the probe's mission may have failed, it continues to teach us valuable lessons even as it returns to Earth. As we look up at the night sky, let's remember the importance of responsible space exploration. The future of space travel depends on it.